So our next speaker today, I'm very thrilled to introduce, is Igor Alexeyev, and his content he'll be sharing with us today is building agentic generative AI apps with Atlas on AWS. Thanks, Igor.
Thank you. Hi, everyone. Can everybody hear me well? Thumbs up, great. So my name is Igor Alexeyev. I'm a partner solutions architect at AWS. I work closely with MongoDB. MongoDB is a great partner on AWS. We have a great partnership. MongoDB has created a lot of integrations with AWS products and services. Their models are deployed on Bedrock, Bedrock Marketplace, and AWS Marketplace. We have integrations with Lambda, with Kinesis. Recently, we also attained this competency of generative AI competencies, how AWS distinguishes certain partners. By the way, actually, who has been last year at my talk? Okay. Okay, some people were. Okay, good. So it's going to be a lot of new material for you. So competency is how we distinguish partners. When you come to AWS, and there are some ISV partners, the consulting partners, how we distinguish them is we have competencies. So if you're looking for a specific partner in a specific area, you look at specific competency, and MongoDB is part of many. Now, this is what I call shock and awe slide. This is how many integrations we have. And you can think of this as you take MongoDB Atlas is in the middle, you grab a service from each quadrant, and you kind of have an architecture that can work with MongoDB. Like you can take MSK for data ingestion, you can grab Lambda for compute, you can grab, say, SageMaker, Jumpstart, or Redshift for data, for visualizations and analytics, and you have an application architecture. Many of these are possible, but main topic today is, of course, generative AI and how to build agents. So recent trends, 2003, people started with POCs, then they kind of 2023, not 2003, 23, people started with POCs, then they kind of started moving to production. Now there is a more question of value. Can we're spending this money on the services, what value are we getting? That's more of from a business point of view. From technology point of view, agentic AI is evolving. So on the left-hand side, everybody started with RAG, retrieval augmented generation, and it kind of was built into, people built assistants. Basically, you had search, you provided context, and you supplied answers. Next, it kind of evolved into generative AI agents, where you have a single agent with multiple tools, and it generates responses. Because you have tools, they're kind of like performing specific tasks, so responses were more complex, and the quality of responses was higher. Now we're evolving into whole systems where you have multiple agents. Each of them can respond or is experienced in this particular area, and there is a multi-agent interaction. Now, AWS has a generative AI stack to help you build applications. You can think of this as 3 layers. So the highest level of abstraction is what we call applications. Kiro, there was just a session, a vibe coding session with Kiro. It's a developer environment where you can code the applications. There is also Amazon Q, AWS Transform. So these are applications require little to no configuration, typically geared either to business users or like Kiro is towards developers, but they're end users effectively. You can customize Kiro, for example, in Amazon Q CLI with MCP servers, but again, it's a customization and it's not like coding. Actually, I assume who are developers here? Software engineers? Okay. Data scientists, maybe? Business executives, CEOs, VCs. Okay, so mostly developers. So yeah, as a developer, you'll probably be using Kiro for coding. I have some slides. Most developers kind of leave this in the middle tier. That's where you have SDKs for agents, for example, Strands. We had a workshop in the morning where I used Strands framework You will be using Amazon Bedrock. Bedrock is where you can get, Bedrock provides you with models, LLMs, and we recently launched Agent Core. Agent Core has its own capabilities, and it's a managed environment for running your agents. And at the lower level, that's where, oh, actually, Bedrock also is where Voyage AI models live. So if you need to use Voyage AI models on AWS, that's where you come to Bedrock. Bedrock or AWS Marketplace. I have a screenshot later. Infrastructure, it's a little bit lower level. This is more for data scientists. This is where you fine-tune the models. This is where you build your own models, customize models maybe. Maybe you distill models. This is more of a data science area. We have custom silicon, we have GPUs, we have Trainium for training models, we have Inferentia. These are custom chips that AWS developed where you can use them for training models or deploying models. Now, we'll talk quickly about Q. Q is a there is one kind of interesting play with the Q. It's a generative AI-powered assistant. Typically, business users do it. But for developers, developers is Q developer. And then specialized users for some other applications. I'm going to quickly skip. The one part I want to highlight is Q-Index. So Q-Index was built with Amazon Q Business. And that's where we already implemented integration with systems on the left. These are typically horizontal business applications. And if you're building a generative AI application, but it needs data from Salesforce or from Jira, you shouldn't be building that yourself. What you do instead, you build your own application on the right-hand side product, it's in the orange square, where you interact with Q via APIs, but you also add Atlas, and you can do some simple RAG, for example. And you combine the both data you get from both sources into a single prompt. That's your augmented context, and that's how they build this application. The key here is to save your time building integrations with these existing systems. Most of the time you will be in Bedrock, so it's a fully managed service that offers you a choice of high-performing foundation models. And we have quite a few of these models. So it has a curated set of models. So Anthropic is a very popular model. I think it's at version 4 right now. Amazon also has Nova family. Nova offers a good trade-off. Like with all the models, you have trade-off between quality, latency, and cost. These are like three triangles. Think of it as triangle. So Nova kind of excels on latency and cost. But you're free to use the other models as well. So Voyage AI models are deployed, so you can see Amazon Bedrock model catalog. There is Voyage 3 embedding model. And on AWS Marketplace, we just deployed Voyage 3.5. And there's like a family of them. So MongoDB acquired Voyage AI. You've kind of heard, you know about Voyage AI, right? Voyage AI models, you've heard, yeah. It's embeddings models. You can use it from either AWS Marketplace or from a Bedrock model catalog. So what you need to do is to provision it, you'll provision an endpoint. It's like a SageMaker endpoint. You'll have to size it to match your workload, and you interact through the APIs with the endpoint to generate embeddings. You generate embeddings, you store them in MongoDB Atlas, you define an index, vector search index, and that's how you'll be working with these models. Just a quick reminder, so it is kind of journey we've been going through. We started with RAG, with AWS and MongoDB on AWS. So this is general RAG flow, everybody familiar with this. And then this is a bit of a history, right? So the simple RAG flow, you can then use it. You can use Lambda, you can call the models from the Bedrock, and you interact with Atlas using semantic search. And this is like the simplest RAG application they can deploy. It is serverless. You don't need to worry about scaling it. Bedrock are also serverless APIs. Atlas has scaling capability as well. And that's the simplest you can probably do. Well, things that get complex a little bit later, but just an example of code. Great, you can see the code. it's a vector search, simple vector search. You get the results, and you interact with LLM to give the results. You're responsible for generating embeddings. When your query comes, like first line, you generate embeddings. You pass them to the search. Search will find matching entries. Now, last year, AWS implemented Bedrock knowledge bases. Bedrock knowledge bases automate a lot of RAG workload, a lot of RAG boilerplate code and features into knowledge bases. So you just give it a file in S3, it will automatically ingest, create embeddings, and load them up in MongoDB Atlas. And that was done together with the MongoDB and Bedrock team. Now, how does it work? Again, you have to have some sort of compute environment, and then you will be interacting with the knowledge bases via API. Bedrock will be responsible for getting the data out of S3, indexing it just like I said now, and Bedrock will be responsible for doing the search. So this is exact same architecture, but now re-implemented with knowledge bases. So what the code looks like now, you can see it's kind of like getting smaller. You basically configure your knowledge base. You give it an ID. You say where it is, how many results you want. And when you invoke, you just pass in it a query string. You're not, like you can see, there is no embeddings generation anymore. That's because knowledge base is taking care of it. Yeah, no embeddings generation, simple API to search. Now, agents came along, right? Everybody wanted to do agents. So with agents, you have many choices. You can use, like this is the simplest possible. Basically, agents need to compute. They need to run somewhere. In this case, you can use Lambda. Lambda is a great compute. And you can use completely open source. LangChain, just embedded into your Lambda code. So LangChain will be responsible for interacting with Bedrock. And you add your what is called tools. And these tools will do whatever you need them to do. Agents will decide which tools to use. And it's a simple code. This is what it looks like approximately. This is a tool definition. Like we did a workshop today. Who was at the workshop today? Okay, good. Thank you. So you defined, this is what the tools were defined. So this tool performs specific lookup. It's a lookup by name. It's a regex expression. Key here, the description, that special description right after the name. It describes the parameters, overall function of the agent. And this is your tool now. And LangChain will construct an agent with these tools, and it will know which tool to call. You can have several of them. And it will be responsible for generating responses based on what the tool returned. Now, that was, we did it with the LangChain, and we did it in Lambda, and it's a kind of like we managing ourselves the agent itself. Now, Bedrock has created Bedrock agents. It's more of a managed environment. It is responsible for you. So with the Bedrock, Bedrock agents will decompose the query into steps, will decide which tools to call, and and will execute several actions. They can go to the agent. They can go to the knowledge base, the integrated knowledge bases. So in this case, it will be simple RAG. If you just configure just a knowledge base and nothing else, it's effectively your RAG architecture. If you add your knowledge, if you add your agents configuration as well, it will perform search, look at the results, see if it needs to call agents, and it will call them. And it will provide a final answer. This is the architecture of the agent. So again, your Lambda will be now more responsible for interacting with the user, but also calling Bedrock agent APIs. When you configure the agent, you have to specify which LLM you will be using, and there is like an agent definition. Yeah, in this case, so what we implement, like in the agents, what I implemented is same tools, but now they implemented as separate Lambdas. The code looks a little bit like this. I'm using Power Tools Lambda framework. So I have a special annotation that describes what this tool is about. Every parameter needs to be annotated, result needs to be annotated, and this way Bedrock agents know when to call this tool. It's slightly decorated, more decorated method than before, but it's equivalent complexity. Now, Bedrock knowledge bases is easy to add here. Like I had another line drawn, I didn't put an icon. So basically, your agent can do custom lookups, but knowledge base can perform an additional semantic search lookups. And this is done at the configuration. You don't need to code the knowledge bases at all. Now, everything is evolving, so we recently launched another service, which also does similar things. It's called Bedrock Agent Core. And that's a family, again, a family of product, and it's evolution. It's both Bedrock agents exist and Agent Core has now existed. And Agent Core has more features. So it has Agent Code Interpreter, which can generate code and execute it. It has Agent Core Browser. It can perform actions in the browser. Agent Core Memory, you've heard a lot about memory today. In our case, memory is managed for you. So you just need to configure it. I want a short-term, long-term memory, and it will be managed for you. MongoDB has its own solution where you have more ability to tweak how that memory is created and managed. Gateway allows access to, I believe, other tools, and there's identity as well for managed identity. But the mostly you'll be spending time with Agent Core runtime. Like remember previously, I always deployed the compute to Lambda, right? And I had to explicitly manage that Lambda to run my application. With Agent Core runtime, you don't need to manage Lambda anymore. What it does, it will take several known frameworks like Crew AI, our own Strands AI, LangChain, LangGraph. It will wrap it in a Docker file, basically create an image underneath, and it will be, Agent Core runtime will be responsible for deploying the applications. And that's what we were doing in a lab today. You basically ran the deployment, it took your code and deployed it to Agent Core runtime environment. Once it's deployed, you have an API to interact with. The architecture is not super complicated. Those people who were in a workshop today, they've seen this. So your app, maybe it's a Streamlit app for example, will be interacting with the Agent Core runtime, which are APIs, that's a service. And in that service deployed your agent, the agent you define in your own code. In our case, it was agent.py. In agent.py, we had all the definition of what this agent does, what kind of tools it has, and what kind of LLM it's using. And the tools will be doing individual tasks. And you can see this search, for example, semantic search, which is a typical kind of part of typical RAG, that's just one of the tools. But there could be many. You could have a direct lookup. You have a regex lookup. Whatever your business logic, you will put into one of the tools. Now, this is Strands example we used in the workshop. So here's a definition of a tool. It's a place lookup by country. Just you add an annotation, special comment, and the rest of the code is unchanged. Very easy to do. And if you have, an actually interesting point, if you are switching between multiple frameworks, you notice the code primarily doesn't change, it's usually annotation, so you're not backing into a specific framework. It's fairly easy to switch frameworks, pick one and just continue developing your application until you don't like it anymore. Main kind of main takeaway here. Very similar, easy migration. Yeah. Okay, cool. But compute is now managed for you. Now we're going to pivot a little bit. You're developing agentic applications, but you can actually use agentic tools to do it. One of my favorite tools is QCLI and QDeveloper. I'll just quickly talk about MCP servers. You've heard of MCP servers, right? Okay, some people did. There's a lot of hype about them. the most important letter MCP server is P. Remember, it's a protocol. It's how interaction is done between the host and the server. So that's what it was standardized. Another protocol is REST. It could have been done with REST API or open API schema, but they invented MCP protocol. So what it allows is, to, well, let's just quickly talk. So what they do, right? So there is a host. You always need some kind of host application. It could be QCLI, it could be Kiro, it could be QDeveloper. Any environment that supports MCP servers, it's a host. That's where you configure your MCP server. MCP server has a collection of, a cloud desktop. Yeah, these are examples of applications. MCP client maintains a connection. So MongoDB has an MCP server. In its configuration, you have to supply connection string to MongoDB cluster. In this case, it runs, I used QCLI chat, it runs locally on my machine, so it's a local MCP server, runs on my machine as well. And it provides context tools and prompts to the clients, right? So when user types something, LLM looks at what user types, looks at the tools available, and decides to execute a tool. So what does it look like in my case? This is an example from the QCLI chat. QCLI chat is awesome. It's an application, and it's free to use, I think, with QBuilder. It knows all CLIs that are out there and how to construct the commands, and is able to execute them. In this case, I said, show me first 5 records in MongoDB app database to do collection. I am typing natural language. It is able to figure out which tool to use. In this case, it knows that there is a collection to do's, and there is a database app, and it's using a tool like find. It executes the query. So what you get here is a natural language to MongoDB API's execution. And you can get more done with it. Let me just see. So just for fun, what I did is I asked it, and you get the results, right? But you can give it more complex tasks. I ask it, for example, give me this 5 to-dos, translate them into French, upload them to S3. It will just go step by step and do it, because there is an MCP tool for AWS commands. There is an MCP tool for MongoDB. It knows how to use them. It knows from your prompt that you want to extract some data, translate, because LLM knows how to translate. They're LLMs. And it knows how to upload to S3. In fact, in QCLI, I can do more things. Like, I even had a troubleshoot my AWS environment. I needed to delete something, and there were dependencies. It can look at the logs and say, oh, I see the error in the logs. It is actually awesome. You don't need to type commands anymore. Don't type commands anymore. Install QCLI chat and just ask it to do the commands for you. Like, if it knows there is some tooling, some CLI tooling exists, you don't have it installed. It knows I'm running on Mac, and so it will say, okay, I want to execute brew install and that tool. It's awesome, actually. All right. Now, Kiro. We just had a vibe coding session. So Kiro is, I assume, who heard of Kiro? Okay, good. Who heard of Cursor? Okay, Copilot. Okay, same difference. They're development environments. It's a coding assistants, coding development environments, but driven by agentic capabilities. You can do vibe or spec coding. It's a similar kind of experience. In my case, this is the prompt I gave. I wanted to create a CRUD application based on MongoDB's collection. Now, I hooked in MCP server into Kiro, so I didn't tell it what in that collection. It was able to go to the collection, sample the records, see what kind of schema to expect, and it was building an application based on that sampling. And it goes to standard phases, right? Once you gave it a prompt, it creates requirements. You see 1, 2, 3. It goes from requirements. Next step, you click it, move to design phase. It generates the design. It's going to be overall architecture. There is like a little bit thing cut off. It even generates a diagram, mermaid diagram. Move to implementation. It creates a task list. And you can start clicking on tasks to to start execution. Yeah, you can see a task in progress, and you're not limited to like your imagination is here a limitation, and the complexity of what you're asking it to do. If it's too complex, break it into smaller pieces. It will start executing tasks, but do review because it is overly helpful. It will try to implement exponential backouts, whether you need them or not. So you're gonna have to review what it's doing. It's a bit of it might go into overkill. You have to constantly trim it, say, yes, now I want to simplify it, etc. So once these things are executed, it can actually start testing it, what you've done. Because it has ability to run commands. You see, like, for example, I'm asking it to create React-based app with the backend running on MongoDB Atlas. Now it's going to run npm run install to configure my Node.js application. It will run the local server for the application, and eventually it will create this UI. Well, of course, fun fact, it created white on white everything for me. First time I launched, nothing is visible. I just realized the CSS was messed up because it cannot see it, but it knows how to generate it. All right, I think with this, I actually want to, there's a bunch of QR codes. If you want to start with Agent Core, if you want to download Kiro, this is the workshop if you haven't attended. And MongoDB asked me to include this. There's a badges, Agentic badges, if you want to kind of earn those badges from MongoDB. We are going to be back at the booth if you have any questions. I have time now, but come to the booth instead. Okay, thank you so much for coming.